Good afternoon, Chem Kids. We're going to go over how to draw VSEPR structures for the main structures that you have to know for the test. This is chapter 8. We're going to begin with methane, and our first panel is the valence electrons. So we're going to break down CH4, 1 carbon times 4 valence electrons because carbon is in group 4. Hydrogen, there are 4 hydrogens times 1 valence electrons because it's in group 1 for a total of 8 valence electrons, and that becomes your total need. In the second panel, we're going to arrange those hydrogens as symmetrically as possible around the carbon because that's what nature does. And we're going to give each carbon 8 electrons, and we're going to do that because every atom wants 8 electrons. So all atoms want 8 electrons except, and you have to know these exceptions, hydrogen, which wants 2, and boron and aluminum, which want 6. Remember, the way we remember this one is drop the ball. That means drop boron and aluminum from the list that needs 8 electrons. The next thing we're going to do is we're going to clean up our pick. And the next panel, okay, so this was the preliminary picture. And now we're going to do our cleanup pick. And the cleanup pick is going to be that you draw one line for every 2 electrons. And then our final picture is going to be when we do our total, shared, and unshared. And remember that the relationship here is that the total equals the shared plus the unshared. What you have to do is you have to look around the central atom and draw, either mentally or with your pencil, you have to draw a box around the central atom and all its connections. So this carbon has 4 connections, 4 total connections. All 4 are shared and 0 are unshared. And you go to your key that tells you what all the shapes are with the yellow box, the shapes in the yellow box that you have to memorize, and you see that a 4-4-0 combination is called a tetrahedral. And then you're going to draw the tetrahedral as best you can. Remember, these little slashes mean that the H is going backwards. This little triangle means that this H is going forward, and then the H on the side. So 1 up, 1 to the side, 1 in front, 1 off to the side. And then you're going to try to, if you can, connect the all the hydrogens and make a pyramid, although you don't have to connect it for the test. The shape name, though, the VSEPR shape is tetrahedral. And the bond angles, the BAs, the bond angles are 109.5 degrees. Okay. That is CH4. Okay. We are now going on to NH3, ammonia. And we do the same thing. N is 1 times 5 valence electrons. H is 3 times 1 valence electron for a total of 8 valence electrons. But this time, the 8 valence electrons are going to take on a different shape. Panel 2 is going to be the preliminary picture with the N and the 3 H's all around. I should really draw them with dots first. So I'm going to draw the H's all around. And I'm going to draw 8 dots around nitrogen because it's not an exception. And all the hydrogens are happy because they have 2 electrons. In panel 3, I'm going to connect those H's. I'm going to leave those lone pairs, those are called unshared pairs or lone pairs. They're part of the 8 that nitrogen needs. Then I'm going to go to my total, shared and unshared. And I'm going to draw a square around nitrogen with all its connections, including the lone pair. And I'm going to see that nitrogen has a total of 4 areas where there's electrons around nitrogen, whether they're shared or unshared. We just want the total. And then over here, we break them down into how many of those are shared, and we can see that 3 are shared and 1 is unshared. So in our yellow box with the shapes, we're looking for a 4, 3, 1, which is a shape called a trigonal pyramid. And the way that looks is one of the H's is behind, one is in front. The other one is also behind. The lone pairs are here. And remember, the lone pairs need more room than the others, so they're going to push these hydrogens closer together and out of the way. And the official shape name is a trigonal pyramid. And the bond angles are 107 degrees. That's our second shape. Our third shape is for water. Water has 2 hydrogens with 1 valence electron and 1 oxygen with 6 valence electrons for, again, a total of 8. But again, these 8 are going to be turning out to be a different shape because of the shared versus the unshared. Okay, so let's see how that works out. The O is going to be this time in the center. Remember, your central atom is the one that there's only 1 of. We're going to put the H's off to the side. H's are exceptions, so the O gets the entire 8 electrons. When you clean up the picture, it looks like this, but you are leaving those unshared electrons there. And we're going to draw a box around oxygen with all its connections, and we can see that the total electrons around oxygen, there's 4 areas. 2 are shared and 2 are unshared. And when you look up a 422 in your shape box, you get something called bent. So this is panel 1, panel 2, panel 3, panel 4. And on the test, you can consolidate these panels. You may not need to go through all of them. It's very important to calculate the valence electrons in panel 1. And then if you're ready, you can skip panel 2 and go on to panel 3. This shape, when you look it up, is called a bent with bond angles of 104.5. And we have to bend this oxygen. So we're going to bend this oxygen, but we're going to leave the lone pairs. We're going to draw those bubbles. That means that those lone pairs are pushing these hydrogens closer together and out of the way. Our next shape is going to be aluminum hydride, AlH3. Panel 1, valence electron count, aluminum. There's 1 aluminum times 3 valence electrons. There's 3 hydrogens times 1 valence electron for a total of 6 valence electrons, total need. Alright, so this is the first time we haven't seen 8. Aluminum is in the middle, and the 3 hydrogens are going to be on either side of it. Now this time, aluminum is an exception. So it only wants 6 valence electrons, so we're going to give it 6 only. Our cleanup pick is going to look like this with the H's with lines. Every line stands for 2 electrons. And when we do the total shared and unshared, we're going to see that the total areas around aluminum that have electrons are only 3. Shared with 3 other atoms, unshared, none. So this is a 330. And when you look up a 330 in your shape box, you're going to get something called a triangular planar. a triangular planar. And the bond angles on a triangular planar are 120 degrees. So we're going to try to draw it like a triangular planar, which is with like a Y, like a great big Y. And the Y could be the way that I drew it now, or it could be the other way with the two H's on the bottom. And as we can see, if this were a circle, each of these angles would be 120 degrees. So that is a triangular planar. Our next shape is going to be something very simple, HCl. And this is panel 1. We're going to start with a valence electron count, 1 times 1 and 1 times 7, for a total of 8. But this time we notice that there's no central atom. And when there's no central atom, you automatically know it's going to be linear, because if you only have 2 atoms, 2 points in geometry, they define a line. And so all you can do is put them next to each other. Of course, chlorine is going to get all 8. And the way this cleans up is very simple, with a line between the chlorine, but you have to keep these dots. There's no central atom, so the total shared and unshared does not apply. Once again, I'm going to repeat that. The total shared and unshared is only when there is a central atom. And for there to be a central atom, you at least have to have 3 atoms, so that something can be in the middle and the other 2 things on either side of it. If you only have 2 things, there cannot be a central atom. It's always going to be a linear. So the final pick is really just the same picture, because there's nothing we can do to shape this. And the shape does have a name though. The shape is linear. And from geometry, I know that you know that the bond angles on any linear is 180 degrees. All right, everybody, those are the main shapes for the test. So we have a tetrahedral, we have a trigonal pyramid, we have a bent, we have a triangular planar, and we have a linear. Those are the 5 basic shapes for the test. In the next videos, I'm going to get into more complicated shapes. I'm going to show you how to do an ion. I'm going to show you how to do resonance structures, and we're going to talk about IMFs.